Hi everyone, welcome back to the Math Tutor. In today's video, we solve the third exercise from the triangle chapter. Okay, so here we have given two isosceles triangles, ABC and DCB. Okay, in the first question, ABC and DCB, this large triangle and this small triangle. Where BC on the same base BC and A and D are vertex. Okay, that is A is the vertex, that means AB equals to AC, and D is the vertex, that means this side equals to this side. Okay, DB equals to DC. If we extend AD to BC, which intersect BC at P, okay, now we have to prove this ABD equals to AC, congruence to ACD. So we have to prove ABD triangle congruence to ACD. This ABD, this upper small triangle and this upper small triangle. So it is clear that since these two part BD equals to DC, these two angles are same. Sorry, these two sides are same, and these two sides AB equals to AC, and the AD is the common side. So by side congruency, these two triangles are congruent. Since these two triangles are congruent, you can see that these two are interior angle and these two are exterior angle of this angle. So by CPCT property, these two pair of angles are same. Hence, this AD, you can say that this AD, extended AD bisect, AP, okay, AP bisect A as well as bisect D. So this proves the third one. Now we have to prove this triangle ABP and ACP are congruent. ABP, this large triangle, these two large triangles are congruent. So in these two large triangle, it is given that AB equals to AC. It is given. Now we have just proved that these two angles are congruent. Okay, and this AP is the common side. So by side congruency, these two triangles are congruent. Okay, so this proves the second one. Now we have to prove this AP is perpendicular bisector of BC. Here we can see that since these two triangles APB and APC are congruent, these two angles are also same by CPCT. And also you can see that these are the linear pair angle. That means their sum will be 180 degree. So these two angles are same and their sum will be 180 degree. So you can write that here this BPD equals to CPD and their sum will be 180 degree as they form linear pair angle. So since BPD equals to CPD, I can write BPD in place of CPD, and the sum of 2 BPD will be 2 BPD equals to 180 degree and BPD will be 90 degree. And since BPD 90 degree, CPD is also 90 degree. Since this BPD and CPD both are 90 degree, hence this AP is perpendicular to BC. Okay, so this is the proof of question number 1. Now come to question number 2. It is actually a quite simple number. So here we have given that AD as an altitude of an isosceles triangle. That means AB is isoscale. That means this AB equals to AC and they are facing angle B angle equals to C angle. Now we have to prove that AD bisect BC. That means BD equals to DC. It is we have to prove. So to prove this, consider these two triangles. Here this is the right angle. Okay, D angle ADB equals to ADC. This is the Right angle has AD is an altitude. Now it is the common side AD. AD is the common side. It is common. And AB equals to AC given. That is the hypotenuse of these right angle triangles. Okay. So it is hypotenuse. By right angle, hypotenuse and side congruency, these two triangles are congruent by RHS. And hence BD equals to DC by this BD equals to CD by CPCT. Now we have to prove that AD bisect A. So it is also obvious that by CPCT property these two angles are also same. That means we can say that this AD also bisect angle A. Now come to question number 3. Here we have given that we have given actually two triangles. Here we have given two triangles. Okay, this is ABC and this is PQR. ABC and PQR, where in ABC AM is the median. Okay, that means these two are same, and PN is the median. That means these two are same. Okay, so here we have to prove that APM and PQN are congruent. APM, this part and this part are congruent. So it is given that AB equals to PQ. It is given that AB equals to PQ, AM equals to PN, and BC equals to QR. It is given. Now, since M and N are midpoint, we can write this BM is the half of BC and this Q1 is the half of QR. We can write that BM is the half of BC and Q1 is the half of QR. Since BC and BC and QR are same, that means their halves are also same. BC equals to QR, half BC equals to half QR. That means BM equals to QN also. Okay, so now this BM equals to QN. So by side congruency, these two triangles are congruent because AB equals to PQ, the first one given, AM equals to PN, it is also given, and we prove that BM equals to QN. BM equals to QN. So by side congruency, these two triangles are congruent. Okay. Now we have to prove ABC and PQR are congruent. Now we have to prove ABC and PQR. Since here we can see that since these two triangles are congruent, that means this angle B is also angles equals to Q angle. Okay, by CPCT. Okay, actually we use to prove the second part. Okay, now consider the large triangle. Okay, ABC triangle and PQR triangle. I have given that AB equals to PQ. It is given. Now this angle B equals to angle Q. It is just we have proved. Okay, now it is also given that BC equals to QR. It is also given. Okay, so by side congruency, these two triangles are congruent. Okay, so this is the proof of question number 3. Now come to question number 4. It's okay. So here BE and CF, in this figure BE and CF are equal altitudes of a triangle ABC. So we have given a triangle ABC and BE and CF are two equal altitudes. Okay, that means they are 90 degree to AB and AC and they are also equal. Now we have to prove this ABC is an isoscale. Okay, so to prove ABC isoscale, we have to show their one pair of sides are same. So to prove this, we just consider these two triangles. Okay, these two small triangles, this triangle and this triangle. Here we have see that this angle F equals to angle E. Okay, these are 90 degree as BE and CF are altitude. Now BC equals to CB. Oh, sorry. Oh, no. Yes, we can do in another way also. Since angle A is a common angle, okay, these two angles, angle F equals to angle E and A is the common angle, and we have given that B equals to CF, B equals to CF. So by angle side congruency also we can prove, we can make these two triangles congruent. So by CPCT, this AB equals to the AC. Hence we can say this ABC is an isosceles triangle. Okay, or you can do in this method also. Otherwise you can consider these two triangle AFE and triangle AFC and AEB, where A is the common angle, A equals to A common angle. Second one is angle F is equal to angle E, it is 90 degree. Now the third one is BE equals to CF, FC equals to EB, it is given. So by angle side congruency, this triangle AFC congruence to triangle AEB by angle side congruency. Hence by CPCT you can say this AC equals to this AB, AC equals to AB by CPCT. Okay, we can use this, you can write this proof also. Okay, or this, here we use our right angle hypotenuse side, and here we have used angle side. Now this is the last question. Okay, so here we have given an isosceles triangle where AB and AC are same. That means angle B and angle C are also same, and we have a perpendicular AP to BC, that is, it is also 90 degree. These two angles are also 90 degree. We have to show that angle B equals to angle C. Oh, sorry. Here we have to prove B equals to C. Actually, it is obvious result, but actually here we prove the property of isosceles triangle actually. Okay, so we cannot use, since we have to prove this, we cannot use this property. Okay, so this is the perpendicular, that means this we consider these two triangles. Okay, since these two angles are 90 degree, the first condition, these two angles are 90 degree, APB and APC, and AP is the common side, and AB equals to AC, it is given. So by right angle, hypotenuse and side, these two triangles are congruent. Hence, since these two triangles are congruent, by CPCT property, angle B equals to angle C. Okay, so this is the solution of exercise 3 of triangle chapter. If you have any doubt or query, you can comment. Okay, and if you like the video, make sure to subscribe to this channel. Okay, thank you.